So I can't screw with this person in front of a couple thousand people he hasn't met, but I want to so badly. I love Dave Foose. So Dave
Do
Foose
it.
is up next. I know I'm going to be
Just,
professional,
just
Dave.
go ahead and do it anyway. It
I'm
doesn't
going to be
really matter.
professional, but Dave is someone that I genuinely enjoy as a person in our ICS community. He's been around for quite some time over at Emerson. I'm taking a variety of different roles from product manager, product security manager, to just getting involved day in and day out with clients. And what I love about Dave is he keeps it real. If it's, hey, this client was doing a lot of stupid stuff that was endangering people, I'm going to say that. Hey, if it was even Emerson doing something, or Ovation that was, hey, let me own it. It's a very, like, just let's have a real conversation about what needs to get done. And I'll tell you, especially for those of the IT community coming into this beautiful ICS community of ours, it is not common for the equipment manufacturers to come to presentations and come to security discussions, because a lot of times they get beat up on, sometimes fairly, sometimes unfairly. And for Dave and his crew to consistently be coming out and having these conversations and trying to engage, it's just been a real joy, Dave, to have you present over the last couple of summits. And so I was glad to see you put in this topic on cloud, because this is something that, depending on what industry you're talking to, it's either like the devil or it is the future and the reason your company is staying in business. And it's almost that binary. So you operate across a lot of different customers. So I'm super interested to hear your perspectives and what you're doing here. But without trolling you, I'll say much love, man, and just good luck here. Thanks for doing it. And we'll see you on the other side of it.
Yes, sir. I appreciate it very much so. And I believe I need to actually go for it. So let's see here.
Yep, just click. Boom. Nailed it.
All right. Yes. All right. So I want to make sure I was actually functional. So I appreciate the overwhelming positivity. Definitely not deserved, but I will do my best. And I really want to say on this one, you're not going to be learning anything super hacky. What I just really, when I approach this subject, is I would also be one of those people who would be naysayers when it comes to cloud, or at least trying to temper some of the more forward thinkers when it comes to this. But I wanted to at least throw out some of the ideas that, well, a lot of what we're seeing is this is customer driven, not us throwing a idea at the wall and see what sticks. So that's what I'm going to do. I'm going to talk about who I am. I definitely don't believe anybody who knows who I am, or even Emerson sometimes. And we're going to get on a small primer on what cloud is and how we got to where we are today. And then I'm going to give some examples of things we're installing right now, or have been installing for the last year or so in my little neck of the woods. And then maybe we'll have a quick talk at the end about what might be next and what we're seeing things are moving towards. So again, who am I? My name is David Foose. I have a couple different hats, but I originally was a IT kind of person over a decade or so ago. I fell into this role because I just did computer stuff for a while. Then I got my master's, and then I went to Emerson mid 2000s. And right before NERC SIP hit for requirements, I was brought in to figure out how to do some of the more IT-like tasks and develop a security stack on top of our products, and then maybe also do some security up to the product itself. So I did that for a large number of years, and now kind of transition over that. That right there, my wife, when we're eating mini tacos, she's a extremely rock star person inside the same company. And most of the time when people ask who I am, I just say I'm Jamie's husband. So I will say this talk, back to that, my caveat will be, it's going to be generic. I'm not going to be naming customers. I'm not going to be spilling much tea. It's going to be very myopic, even though I am here from Emerson. I am from only the power and water division side of it. And I'm also going to be talking about stuff I have seen or been involved with, and it will not be absolutely not comprehensive or really tell you about all aspects of cloud and such like that. So who is power and water, and where do we sit? When we talk about Emerson in general, there's two business units inside of Emerson. One is called commercial and residential. The other one is called automation solutions. My section is underneath the automation solutions side of the house. We have a sister division called Delta V. You may run into them more often than Ovation. But we are based out of Pittsburgh. That's where I'm sitting right now. Our primary corporate location is out of St. Louis, and you'll see a lot more people in Texas for the sister divisions, the Delta Vs, and others that you may run into. So we are very, very big inside of the United States, and in some other certain world regions, but also large municipal water supplies. The big cities are running a lot of our stuff under the covers, and also the security stuff that I would help them out with. So when we start talking about cloud, or at least we need to start talking about what we normally had and what we had traditionally. And so when you talk about a traditional plant build, and especially, you know, going back one slide slightly, we're also used to be Westinghouse 20 years ago, I guess now 30 years ago. But we are still have a relationship with Westinghouse, and the AP1000 is a lot of Ovation under the covers, both hardware and software. So when we build one of these nuke sites, one of the wife's first jobs when she got hired on in around 2000 was working on a data link for a particular type of gear. And to tell you how long some of these projects take to come online, especially a nuke, that she started that right with her first year of programming inside of Emerson, and they were doing first fuel load in 2019. So nearly 18, 19 years later, they called her up with some questions about what's going on and how to make this thing work correctly. So she had to put on her hat and go back to really old notes to figure out what's going on. But you have these large plants, these fiefdoms, these walled gardens that you build, and the capital expenditure is high, and you have to get it right the first time, and you're going to be living with this for decades. In some cases, especially in a nuke space, we're talking multiple decades. We had a nuke plant who wanted to have a service contract for 50 years. So that means we're going to have stuff sitting in the field for a very, very, very long time, and the project for just installation could be over a decade. This was expensive. This doesn't really scale very well with technology, and people oftentimes can't embrace hardware or software that may be on the edge, and they really started thinking about this in a different way. And we watched the IT side of the house, especially the business side, take these some leaps into some spaces that help them conceptually. And that's where we get into kind of what virtualization is. And just to give you a quick primer on what virtualization does, then at this point, you take a piece of hardware and you put a normally called a hypervisor, a different kind of thickness to it, and you place that on top of the hardware, and you put an abstraction layer underneath, and then you put guest OSs. So you have your host and you have your guest OS sitting at the top, and those little bubbles, they speak down to the hypervisor, and the hypervisor provides RAM, memory, CPU, whatever it might be, and schedules it at that point. So once you have now reduced the physical aspect of a thing and where it might sit, you can do some really fancy things. Like one of the draws for a lot of people when they do virtualization is that they think they have hardware obsolescence. If I can make a VM of a thing, it should be able to live on any kind. The thought process is it should be able to live on any kind of hardware, as long as that abstraction layer still understands how to take the calls to it. So it can be moved around because of disaster recovery. It can be moved around because of just having different locations. So once you have removed the idea of the box that does the thing, and you put it into a bubble that can be moved from place to place on hardware to hardware, the world is your oyster at this point. So what does that mean when I have an on-prem location, on premises? I can now move that to other locations, and we're going back for the graybeards we'll start remembering this as data center. So now I can do some abstraction right now of my thing. It runs in some place, and really I'm just receiving some kind of service from it. I know it's running somewhere. I'm sure enough nerds in the audience here have enough devices on their network right now at home that they aren't sure exactly where it is, but it responds to ping. And that could be the same kind of situation we're in. So once we get into the idea of, well, it doesn't have to live here, it can live just about anywhere, you end up with the idea behind cloud or fog or edge or on-prem. So when I move, I kept myself from actually doing it. I didn't say cloud is just other people's computers, but it is technically taking the idea and moving it outside of the realm or the stuff that I build and moving it to another place where they're now handling the power and the hardware, and really now there's an abstraction to it. When you talk about fog or edge, the idea is you're taking cloud or some kind of service or and maybe capability and bringing it closer to my premises and my borders and the physical locations I'm at. So fog was a cute little term for Cisco probably about 20 years ago, which I still hold on to that and giggle about, so, and I use it. Edge is you're taking a device, normally it's a device of some sort, and then it's almost all marketing, but it is taking a physical thing that's sitting on your system and either is running the cloud-like data retrieval from there, and everything is all the processing is done from up above and brought back down to you and giving you an interface, or it is maybe it is just a gateway up and out for data retrieval and manipulation and brought back to you. So you'll see a lot of people talking about we need to edge devices. Well, edge means I have my trusted network, if you really want to say it's trusted, and then I'm on the edge of that and sitting on a untrusted. So when you tell people I'm going to be using edge, you need to make sure they understand that they also are saying the edge of what? The edge of my trusted place I control versus something I don't control, which might be the internet at that point. So you have to make sure the devices are knowingly able to handle untrusted traffic. So when we talk about as a service at that point, it is the various spectrum of moving from one side to the other. Infrastructure will be just, I provide you my gear. You're going to put your own OSs up there. You're going to put your own development up there. I'm just running the data center for you. As a platform as a service, maybe I provide you some kind of tools that helps you build your own products. But a lot of times you're still bringing a lot of your own developers in there. Where you see a lot of people moved when they start thinking about cloud is more of the software as service. That's going to be like your Gmail or your Office 365 or Salesforce, where the environment is already built. You didn't have to build the software. You're just receiving a service of some sort and an interface at that point, and maybe it's your data and what my end devices inside of my environment is still under my control. I just may be interfacing with the cloud-like providing data in a special way. Then we move all the way out to desktop as a service or device as a service. At that point, you have given up the piece of hardware that's in your hands or in your facility to the outside party. So at that point, they can just shut it off. If they don't want to support it anymore, the service can stop. That sounds scary, but you are already using these on a daily basis. Your Rokus, your cell phone to an extent is basically a walled garden that is a experience given to you, especially in the iPhone type ideals. I'm receiving a catered experience, and eventually that hardware is no longer viable for the experience, and they will just no longer let you use it anymore. There is some various levels of that, but it could be also very cheap. If you think about Amazon does a lot of this. So their Amazon Kindle experience, if you're on as an Amazon customer, that device is basically useless unless you want to brick it and do some root it and do some stuff like that. So really what you go from left of having all the ingredients to make dinner to just showing up at the restaurant and receiving the cheeseburger that everybody gets. So why cloud? Why is it a big deal? You're going to probably get pushback from a lot of your people inside your organizations. It's a big market. We're looking at millions, if not billions, of dollars spent. And if you look at the players in this field, they are pretty much have a good slice of the pie. I'm seeing a lot of push from Microsoft, but Amazon is the 400-pound gorilla at this point. But if you look also on this listing, there are some names you've maybe never heard of, like Alibaba. If you're just a US-based person, we're talking about clouds or service providers who are in other parts of the world and are very important to that market. So we are only going to see more usage by your IT firms. If we were talking to you at 5 years or 10 years ago, you would say absolutely nothing. We don't use anything cloud. No. But 5 years ago, probably a number of you are already using Office 365 in your corporate environment and don't really own your mail or your Office or your backups. Maybe a little bit, but not much. So we are now becoming very dependent on if the East Coast of AWS goes down, we see a lot of people get very antsy. There's always that joke of if Slack's down, what do people do? And that's really kind of the truth. So what are some things of benefits? We already kind of somewhat talked about it. The cloud can bring you the ability to do more disaster recovery or storage that you don't have. I don't really have to think about how much data I'm storing. I'm paying by the bytes or how much I use. So I might be able to rank it based upon, I don't have to build a data center. I don't have to find power or racks, or I don't have to do all this stuff. It may be way more cost efficient at that point. Also in the bottom there, which I'm trying to display, is that you're going to have similar experiences for cross devices and cross people all across the world. So if they want to see your interface for your data or want to interface into your application, or customers want to see something, they're going to get the same experience pretty much all over the world, unless something is getting in the middle. Some headwinds you're going to see is you're going to get a lot of vendor lock-in. If you've had any experience working with Microsoft Azure or AWS, they say there's ways to migrate, but is there really ways to migrate? If you do try to migrate, you're probably going to have a whole lot of issues doing that. They're not going to want to let you go. You have compliance. That's what the green symbol there is mean for compliance obligations. We are getting a lot of issues where there's data sovereignty and going on, and a lot of balkanization of security technologies at this point. So you'll have a China for China, a Russia for Russia, United States who will only want their data to stay within a certain kind of geographic area. So if I'm now limiting my ability to move data around, am I causing any more reliability issues as a cloud provider or as a data provider or massager? If I'm using, your data may stay within the certain kinds of United States, but it may be worked on by people from other parts of the world. Is that a problem? And these kind of answers or questions answers to the questions are still not fully worked out at this point. And then the final one down at the bottom, it gets really complex really quick. People who have worked on these, they have multi-cloud environments. They don't really understand that, this device is using this type of cloud, but that device is using this cloud. You may not have a full control over your own organization, and they may be spinning up. You're trying to make them all use OneDrive, but they're using Box. You're having data issues, identity issues, and storage issues, and it can be really hard in a multi-cloud environment to keep a wrap on everything. But the fun part is that you don't get a choice. The business leadership is going to probably define your risk tolerance at this point. We're using cloud now, good luck. Or as NERC has already done, hey, you're going to use the Align project and it's in the cloud, good luck. Now they're going to do some vetting, and I'm not being mean to NERC, and I know I'm going to get yelled at, but it's going where you are using it, maybe you don't realize we're currently using it. So when I talk about security products or projects, there's really two things I want to talk about, and I'm already running out of time. Cloud delivered and cloud native. So cloud delivered is something when I have a project or some kind of interface up in the cloud, and the person outside your organization is providing you security down to your organization at that point, or your endpoints. That could be helpful if you have multiple groups inside your own company who need to look at the same UIs or do actions to those devices. They may be also geographically diverse. Cloud native is more than just a buzzword. If how we do rights management, where the buckets are stored, what about devices or spin-ups of CPU needs, and those things are ephemeral. They may only exist for a few seconds while services are needed. I need to have the ability to understand they existed, and then let alone how the data was accessed and where it was pulling from and was it even allowed. And don't mention things that are on a physical premises issue security-wise, which are no big deal, like speculative execution and vulnerabilities in CPUs may not be as big of a deal for most people. When we get into the cloud environments, it's kind of a big deal if there is a malicious VM looking at various parts of the cache memory at that point. So pick your company. So if you want to do security inside this space, I'm sure there are dozens, if not hundreds of companies who can't wait to take your money and your time at this point. You're going to have to find somebody who not only understands your mission and your business, but also will exist more than a couple of years before they either fall out of the company or get acquired, and now you're just talking to Cisco again. That's a little shot at Cisco. So let's give a couple minutes on some of the examples of what we're seeing from customers right now. Again, I'm talking about power generation. Big ones are M&D centers, management and diagnostic centers. So we're having a large number of fleets who are coming to us and saying, I'm running out of people. A lot of people are retiring. What do I do about these turbines or whole plants, or I have a whole lot of, NERC SIP stuff. I have a whole lot of lows. I don't want to increase my my obligations, but maybe I'm just doing data retrieval. Maybe I'm just pulling it all together to do one big data lake of some sort in my premises. Now, we're not putting this in the cloud, but it is offsite data retrieval from downstream locations, and it's kind of cloudy or foggy, if you really want to say. So how do I centralize all my efforts, all my people, build a, lack of a better term, a SOC of some sort, but mostly an M&D center. And then we try to piggyback that at the same time period with security. So can we at least do reporting at that point, do some trending at that point, but you have to make sure security-wise and compliance-wise that control doesn't leak or is available from one site to another site. Otherwise, you end up with compliance obligation issues where you now have a pivot point for attackers at that point. So there are various levels of figuring this out with the end customer. Their personnel may be there, but we're dropping in to do some kind of level of data manipulation or enhancements or other kinds of things, and building like we have up there digital twins. Maybe we're doing, we'll talk about that very soon, some kind of simulation or other kinds of backups at this centralized location. Real push right now in renewables. I think we've already talked about that in a couple of different presentations, but it's an interesting space right now for renewables. We have situations where the actual engineering team may not exist in the same country as the place where the stuff is. It may be across the whole country where people on the East Coast are taking care of wind farms on the West Coast. They may be across a very large country in Latin America. They may be wind farms off the coast of the United States being handled by a European company. So what do we do about that? They're also being ran by IT groups oftentimes. These they're not considered critical to the grid. So oftentimes control engineers are not the full capital people involved with it. So the IT groups are handling a lot of the building this out because they're not as critical to the grid, and they can get involved with figuring out what they want to do. And they're going to use the same kind of tool sets they have as their IT side. So they'll start asking for you to put it on cluster environments that they already own. Can we just do it on a laptop, or use kind of PLC kind of based stuff where I'm doing all my engineering on a laptop and then walk around to all the wind farm sites or solar sites and update them that way? They may be HMI in the cloud is a definite item that they want to do, and it is pushed very hard. I put that into hydro as well. A lot of hydro facilities, people in Europe taking care of stuff in Latin America is a thing. So we get a lot of push where if we lost one particular site is not as big of a deal, one generation, but I don't really want to have a single pivot point at this point where I'm causing most of the wind in the Midwest to go out. But I don't know if we're really considering or trying to consider the aggregate at this point, because it could be problematic. Simulation and digital twin is always a big deal. We have a lot of training, people wanting to build their simulators into offsite because, again, capital equipment is no big deal. If you ever dealt with a simulator or having to build one, it's a lot of effort. Once you actually build the simulator and use all the equipment, you have to pull your data in, and it's normally a one-time deal unless you do these special tieback systems or what kind of fidelity and level of fidelity you're going to get for your simulator. Make one change on your production environment, and it may or may not make it into the simulator. Now the simulator is just crap, and you're going to have to pay somebody to come in and rectify it. If we're talking about real time and these environments exist, we are using controllers as simulation control, and we're using algorithms that we develop ourselves to show physics, and that's how we do simulation. It's how we do a lot of our development, is in a simulated environment. So before we move it to a physical environment and give it to customers. So this is stuff we've been doing for decades, and now customers are pushing to do actual control with a virtual controller. And that is happening in certain locations, but it would you're still going to have some level of physical there because the IO, the valves, the pumps are still going to have to be physically there. But there's still going to be a interface coming from the virtual environment over Ethernet, because we might do remote IO through Ethernet at that point. These are great if you want to do online simulations or as a backup recovery of your environment. Maybe I can look at it like almost like GE's Digital Ghost item where if the physics in my simulation doesn't say something's right, then it should not be happening over here in my physical. If I can go forward and backward in time with these, so I can kind of plan where something might go if I make a change in the control. So DCS as a service, I throw that in there to make everybody scared. I don't believe we are there yet for a full DCS as a service. If you do go that route, are you prepared to have, if you didn't pay, that it just won't work anymore? I don't think anybody's ready for that at this point. Does it make sense in small little control relation items like we're talking about microgrids or solar or wind? Possibly, but again, I don't think there's going to anybody have the stomach for allowing you to shut them off if they don't pay or the company goes out of business. We are still seeing some provided services, perhaps additional ability to do data enhancements or various types of restorage. I can maybe do backups or give you kind of disaster recovery or even the simulator as a service. That way you don't have to do as much the actual equipment and maintenance at this point. We're already doing virtual FATs where people are getting into a virtual environment of their actual simulated environment of their plant and doing checkouts of logic and graphics and stuff like that. But I don't really see full control just yet, other than in the small sections like we're seeing in renewables, where it's kind of where the Wild West at this point. So last thing before I have to be told, get the hook really at this point, we did purchase a company, OSI Soft, not OSI Soft, OSII, Open Systems International. They are a transmission distribution company. So we're looking as Emerson from generation all the way down to the home at this point, or at least in the distribution portion of this. And we're looking at microgrids and the actual renewable sector. And it's going to be real interesting to see the whole life cycle from generation, because right now, especially if you ask anybody in Texas, generation is really important. And we might be seeing a lot more micro generation going on where we're tying a lot of these systems together, and definitely having to do a lot of remote capabilities at that point. And we're definitely going to try to make things smarter and more sustainable. And that's where virtualization comes in. That's where the cloud could help. But again, what is your tolerance for outages at this point? And I don't know if we were there yet. I don't know if we have the 5 nines yet. And I'll leave it at that this moment.
You get the benefit of having Rob intro you and me take you out.
Yes, sir. You've been waiting for years to take me out.
Yeah. I guess there's a sea of questions that it's not even worth me trying to lightning round you. But I guess I do have one question. As for myself, as I've looked at different vendors and different asset owners, kind of pursuing some things, and I would say across the entire spectrum of cloud and fog and on-prem and edge and all the different things and considerations for managed service and information protection, there's you start to get more and more to a concerning point. And one of the ones that I was more concerned with was kind of a concept of a completely unmanned and
Yes.
remote managed combined cycle gen. But as you've seen kind of people pushing and what we'll call, kind of pushing the boundaries of what we can do and how we can do it, what's been something that's been of the most concern from you, that where you'd say that is something we absolutely cannot do due to safety or reliability, or something that's clearly in the bounds of we should never really be talking about it this way?
I hate to never say nevers on that one, because again, we can say autonomous operations is a really bad idea. And we've had a number of CEOs look at us and say, if you ever put my power plant in the cloud, I'll kill you. But then they're at the same time period, they're having the same conversations with us at this point, with saying, I have a lack of ability, I need to figure out better OpEx and CapEx, and there's no way, I don't have the people anymore, and I'm going to have to shut these plants down. What can I do to extend their lives? You got to find a better way to make this happen with the same team of two guys who are doing all the work for the whole fleet. Especially when you talk about a lot of those operators out there who are just talking security wise, when you start talking to these really large companies, they'll have two people who is their ICS experts working for the whole fleet. And it's like, I get you right now. And we're going to have to, it's for us as a vendor and us as the experts to not say the no, but to provide the how in a way that doesn't allow them to do the bad, I guess is the easiest way to say it. So we're going to have to find, frankly, automation is one of the words of our whole area. So we can't be scared of automation in other fields at this point. So we have to find a better way of doing this and give people the tools they need to do it correctly.
That's a great answer. I appreciate your perspective on it. Thank you very much, sir. Great talk. Super glad to have you here. I hope you're at every summit going forward. Just like always, a great message for the industry. Thanks again, Dave.